policies, like network policies, RBAC, pod security policies on a bunch of namespaces at once. Tons of mission control and tons of service mesh complete each other. Let me explain how. So tons of service mesh, as I showed you, allows you to operate on the application, not on the clusters. So you can actually move your services anywhere you want and do whatever you want with them. You don't operate the cluster. But tons of mission control operates multiple clusters at once. So I can take a backup policy and a RBAC policy and a network policy and apply it to a cluster, and then tomorrow apply it to another cluster. So it's basically abstracted all the cluster operations. So together it's pretty powerful because you're actually making your clusters a non-issue. You have a new cluster, you put it in a new cloud, attach it to a tons of mission control policy, you get all the RBAC, you get all the backup, you get all of that, and attach the services that's run into a tons of mission control global namespace. And at that point, you're operating on the abstracted application, not on the cluster. That was a free run went on tons of mission control.
And so that was TKG running on AWS in the example?
Correct.
Okay, thanks.
See how I managed to take a single word answer and make it like a pitch? Whatever.
That's your experience showing.
Any other questions? Cool. Thanks for having me, Steven.
No,
Thanks.
thank you. If there's anybody has questions, what is a good way to get in contact with you?
If you know out of VMware Twitter, I guess. Yeah. Niranec, N-I-R-A-N-E-C. Easy to find.
Cool.
Thanks, guys. Later.
All right. Thank you.
Thank you.
All right. Next up, Ramirez. He's going to go into a deep dive on NSX for us.
Hey, good afternoon, everyone. How's everyone doing today?
Great.
Can you hear me all right?
Yep,
Yes,
you're
sir.
good. Okay. I have put together a presentation, but if we want to get into a demo at any point, let me know. Can you see my slides?
We can.
Look great.
All right. Perfect. So I'm a network and security TAM. I actually work with a lot of local customers here in the Seattle area, mainly UW Medical with Stephen, and also I work with Boeing in the province of British Columbia. So I'm their NSXT kind of expert on site, or their local, or I should say I'm kind of their advocate internally for VMware to help them deploy. So I put together a brief agenda to cover some of the use cases of NSX. It's like 2 slides. Then I'm going to go into the component overview, talk about how each of the components talk to each other. I thought I'd drill into the NVDS and virtual segments because this can be somewhat confusing for some customers, and walk through how these are built out. And then I think, Stephen, correct me if I'm wrong, but I think I have like 45 minutes, right? We can focus on some logical routing and firewall architecture if we have time.
Yeah, 45 minutes-ish.
Okay, perfect. And if we want to jump around, if anyone's like, hey, that's boring, let's jump to logical routing or firewall, please say something. And then last thing, I'll just do some learning resources. All right, so NSXT is meant for everywhere. I'm sure everyone's seen kind of these sales slides, but it is full-featured layer 2 through 7 platform. Everything from dating back to multi-hypervisor NSXV. We provide, overlay switching, overlay networking, routing, logical routing at the hypervisor, and with virtual appliances and now physical appliances as well. With NSXT, we do internal firewall IDS. We also do WAF with our acquisition of Avi. I think, Aaron mentioned that before in his presentation, and obviously Service Mesh, which he presented on. And then on the SD-WAN side with Velo Cloud, we have a lot of cloud connectivity, routing, security, and access capabilities as well. This is kind of what the portfolio looks like today. So just so everyone knows, like we have for visibility and automation, we have integrations with Network Insight or vRealize Network Insight. Network Insight's actually the cloud SaaS offering. Verni is the on-site, on-premise offering of network insight for visibility and network discovery. We integrate with vRealize automation. I'm sure everyone's heard of how we do automation with NSX network services, but down below is kind of the meat of the presentation where I'm going to start. So I'm going to start talking about NSX Data Center. I'll touch on NSX Distributed IDS and Network Intelligence. We do have NSX Cloud for the public cloud, native public cloud offerings. And then we have our Avi acquisition, which is our advanced load balancer and service mesh capabilities are added to that, and Hybrid Cloud Connect. So to get into the management services, so I'm not wasting too much more time, but this is kind of the components of NSX at a high level. So in NSX T 2.5, 2.4, I believe is when we introduced this capability, but we've collapsed the NSX manager into the controller service. So now we have 3 virtual appliances that scale out and provide redundancy. These are our central point of management for integration with cloud management and automation tools. It also integrates or points to cloud services managers. The NCP is what allows us to provide services inside of container environments, and then obviously we integrate with vCenter. The one thing to note here is NSXT does not have a vCenter plugin, which is good and bad as well. If anyone on the call is a vCenter admin, you no longer have the ability to administer NSXT directly inside vCenter, but NSXT has its own UI, which we can walk through if we want towards the end of the presentation. The data plane changes and expands in terms of its capabilities. In NSXV, we only focused on ESXi hypervisors. With NSXT, we now have VMs containers running on both ESXi and KVM hosts. We also have agents for bare metal servers. And then we have NSX edges that are edge services gateway, are kind of similar to edge services gateways in terms of providing those stateful network services like VPN, firewalling, load balancing, and physical to virtual pairing for network services. The other big feature is the public cloud access. So now NSXT is running in VMware Cloud on AWS. We have, with NSX Cloud, you can run in native Azure and native AWS. And this is kind of the data plane and workloads provider. So I'll start with the managers. So the managers are still the management point for UI. So you'll log into the UI, or you can use the API to make calls to the NSX Manager cluster. This is the entry point for the system, and it handles all queries. Once you get below that, you can actually deploy these in different architectures. So you can have 3 managers independently deployed here on the top right. You could put a load balancer in front. You could use an external appliance to load balance across each of these NSX managers, and the load balancer allows you to keep them possibly on separate networks. So if I want to put on segment A, segment B, segment C, that's a possibility with an external load balancer. The bottom case is predominantly what we deploy with most of my customers is you'll have a segment, single segment, and then you can assign a VIP. When you assign a VIP, a virtual IP to the cluster, one of the managers takes over as the primary for the VIP, and any UI changes are replicated across the cluster to the nodes that they manage. Any questions? All right. So the next component inside the manager appliances is the controller. Now the controller is what we use to pass all ephemeral runtime states down to the transport nodes. So any stateless configuration is crunched and then pushed via the local control plane agent to the transport nodes. These could be ESXi or KVM hosts. And the local control plane agent is what basically enforces the realized state that the control plane is pushing down. Once that, hold on 1 second, it's over here. Once the local control plane passes the stateless information, what happens next is the management plane agent reports back to the management service running on the controllers, and it is now realized. So, configurations like switching, routing, firewall services are managed locally, and then the management plane agent reports back the state and status on each of the transport nodes back to the management controller cluster. a quick overview of the ports and protocol services that we use. So you can see here we use TCP throughout for communication and data plane synchronization. We use DDP. You can see here NSX Manager Controller, which is funny. This is actually services that are used to talk amongst the controller managers, and then within them they're using UDP ports 11,000, 11,004. You can see here the ports we use for NTP, DNS, syslog, and then for SSH, obviously TCP/22 and SNMP, UDP/161 to communicate to each of these services. All right. So the next thing I wanted to talk about was the NVDS. So this can be quite confusing because in NSXV, when you prepare an ESXi host for deployment of NSX, you're deploying the VIBs, the VMware installation bundles, onto the host, and the VIB is then enabling NSXV to establish overlay networking via the VM kernel port for VXLAN. In NSXT, we moved to Geneve overlays, and we also enabled the ability to have on a new virtual switch that's designed for NSXT to be overlay or VLAN-backed networks. So VLAN-backed network would mean it's very similar to NSXV, where you can have VMs remain on a VLAN network and still have the ability to apply firewall policy. The overlay networking allows for you to stretch the overlay network across multiple segments, across multiple networks. And I should say transport networks, but what that allows us to do is have stretch Geneve networks. So transport zones are defined on the NVDS, and the NVDS presents those logical networks that we configure over the top. In my next slide, I'll kind of get into how it all maps together. I call it my spaghetti slide, but the segments are the layer 2 broadcast domains that are configured, and they can be, again, VLAN or overlay. And then the transport nodes attach to the transport zones, and then they access the segments that are presented within that transport zone. Any questions there? Clear as mud? All right. So relationship between the NVDS and the host and what we call an uplink profile. So inside of NSXT, when you configure an NVDS, you'll define a transport zone. Again, up here in the top right, the NVDS will have a transport zone for overlay, and you might call this overlay transport zone or overlay TZ. The NVDS name is lab NVDS, and the type is overlay. You'll configure another transport zone in the UI where you define a VLAN transport zone. Keep the NVDS name the same, and then you change the type to VLAN. Then the next component you'll configure on this NVDS is the uplink profile. So you'll define a teaming policy, your active and standby uplinks, and then the transport VLAN for your tunnel endpoint network. And the tunnel endpoint network is what we use to communicate all of our overlay traffic. So then I'll go into, after I prepare the host, for NSX, and then after I prepare the host, it should have this TEP network, it should have the uplink profile, the NVDS and the uplinks configured. Then I'll go and define like a VLAN back network, VLAN 10, and create that VLAN segment and associate it to the transport zone. And then I'll do the same for an overlay segment for a web segment, for instance. And that has a virtual network identifier of 7001. Now that VNI, just like an NSXV, is going to be above 5,000 and go up to about 16 plus million. So something to keep in mind is individual uplink and an uplink profile can be a lag. Uplink profile is just an abstraction of the physical ports, the VMNICs or PNICs on the host. Any questions there? No questions? All right. Silence is golden. Here's the provisioning steps. So as I mentioned before, so the first thing you create is a transport zone. I'm using overlay here as an example. This is from the NSX T2.5 UI. In NSX T3.0 and higher, it changes ever so slightly because in NSX T3.0 and vSphere 7, we have collapsed the NVDS components into the VDS native hypervisor switch. So you no longer have to provision this. It looks slightly different, but you'll still have the ability to identify the host membership criteria and the traffic type when you define the transport zone. And in NSX T3.0, they actually have a default overlay and VLAN transport zone defined if you don't want to do that. Then you'll define an uplink profile. So inside of here, I'm defining an uplink profile for my hosts. And in my host, I have a failover order of uplink 1 and uplink 2. I could change this to load balance based on source ID and have both active uplinks, uplink 1 and uplink 2. And it'll actively pass traffic between both based on source ID hash. Down here, you have a transport VLAN where you can put the VLAN ID. And then I highlighted this because if you leave it empty, the default is 1600. We do recommend 1700 or higher for Geneve because we have added header flags and metadata that we can add to the header information. Next thing is you prepare the hypervisor nodes. So here I'm adding a hypervisor node manually. In NSXT, in most cases, what you'll do is you'll create a transport node profile, which is slightly different than me doing the manual host add. And what I can do is I can select a cluster and apply this profile to an entire cluster that I create. So, and that's through vCenter integration. So we'll point a compute manager to a vCenter, and that vCenter will then provide us the host clusters, and then we can prepare an entire cluster at once. What's important is that when we create the NVDS, you're going to define the transport zone that you want this cluster or transport node to have. And then you'll configure the NVDS. So you select the NVDS, it automatically populates the associated transport zone. I didn't talk about this, but we have a network IO control profile that you can customize per node or per transport cluster. And then you define that uplink profile. So here I created a transport uplink profile. This would be like having active uplink 1 and 2, or failover order uplink 1 is active, uplink 2 is standby. You'll enable or disable LLDP. Then you select your IP assignment for your TEP, your tunnel endpoints. So I have an IP pool called TEPs. And then I define my physical NICs down here. So VMNIC1 would be associated to uplink 1 in this case. And then if I wanted to add another PNIC, you add VMNIC2 and assign that to uplink 2. You also have the ability to do PNIC only migrations or VMK migrations or uninstallation process. So if I have VM kernels and I want my ESXi host to only have an NVDS and not have an associated VDS, you can actually migrate the VM kernels for management, iSCSI, vMotion onto the NVDS as well if you need that. And then you just have to define the VLAN IDs, which I'll get into a little bit later, to associate those VMKs to those networks. The last step is just creating that web segment or an overlay segment. And inside of NSX, you go to networking and then you go to segments, and I create that, and you can connect here. You can see here you connect directly to a gateway. That would be either like a Tier 0 gateway or a Tier 1 gateway, and I'll get into what those are in the logical routing. But define a transport zone. I selected overlay, but if I wanted to use a VLAN back network, you would select the VLAN type, and it would remove the gateway selection, I believe, and then the next thing would be just be to define a VLAN ID for that network. And that's about it. Any questions? Usually this is the most confusing part of NSXT, is getting the NVDS and the uplink profiles and the TEP network all defined and configured. So sometimes it's a couple layers, as Niren mentioned, a couple layers of abstraction that can be a bit confusing on how everything's connected together and how it's used. So, all right. Well, that gives us more than enough time to start talking about logical routing. So I'm going to start talking about the NSXT edge nodes, the Tier 0 and Tier 1 gateways and what they do, how they're architected. So just to do some introductions on what they are. So we have a physical router up here, your standard, Cisco, Arista, Juniper, whoever, HP, Dell, physical router that we peer our Tier 0 gateway with. On the tier 0, you'll have an uplink defined that we use to peer with that physical router, and then you'll have downlinks. The downlinks are what associate to overlay segments, or they could be associating to a tier 1 gateway if we had multi-tier. I'll talk about what that is. Then you have your overlay segments that are connected into into the tier 0, and then you'll do things like dynamic routing or static routing to pass that traffic to the physical network and then receive as well. These also act as a services router, so there are 2 components I'll talk about next, but they can provide things like load balancing, firewalling, VPN, and NAT services as well at this tier 0. And this tier 0 does break into 2 components, as I mentioned. There's a distributed router function, which is present on all host and transport nodes, edge nodes. And then we have a services router, which is only present on the edge node itself. So when you deploy an edge node, you're configuring the services router for a T0 or tier 1 for those advanced stateful network services. And it could be things like BGP routing in an active-active configuration, or in an active standby, you could be using it for load balancing, firewalling, or NAT. So this is kind of I like this analogy. It is the on-ramp, off-ramp for services north to south inside of the environment. The distributed router is what runs our east to west, and it runs as a kernel module inside the hypervisor. So when I create a T1, for instance, and run it in DR only mode, that means it's running as only a kernel module across all edge nodes and transport nodes to peer with the SR, or the DR, I should say the DR of the T0, and as well as it is the default gateway for all those segments. So this is our distributed east-west router. To drill into the SR just a little bit further, what you can see here is our services components and what we provide in terms of those services. It does routing, it does physical to virtual gateway connections, it does NAT, load balancing, as I mentioned before, DHCP, firewalling, and VPN. And again, it's only instantiated in inside the edge nodes. So just to kind of give you a quick tying it all together with a multi-tier architecture. So here we have a tier 0 that we configure, and inside the tier 0, we have 2 downlinks and then an uplink to the physical router. So what is created is a DR service that runs on all the hypervisors, the transport nodes, the edge nodes, and then we have an uplink that we create, and that then instantiates the SR with the edge on the edge node. And the edge node is then configured with that uplink interface. In between, we have an inter-router link. The inter-router link is what we auto-plumb between the DR and SR all of our network services. So this inter-router link will advertise to the SR our 10.1.1 network and our 10.2.2 network. So this now advertises to the physical network if we identify that in route redistribution. And if you look at the route tables, each of these are kind of actually a VRF inside of the overall tier 0 or edge node. You can actually see the route table for the SR. You can see the route table for the DR as well. This is that multi-tier topology that I mentioned. So here we have the tier 0 is kind of our active or active standby uplink to the physical network where we're passing traffic. And then below that, we have our tier 1 router, which, in this architecture could be used as like a tenant-based service. So I can have a tier 1, and then on that tier 1, you can even push down the stateful services to say, I'm going to terminate my load balancing, my NAT, my firewalling for that tenant on the tier 1. And then I'll have all my tenant-based segments behind it, behind the tier 1 gateway as well. Benefits here, tenant isolation separates control from the infrastructure and the tenant administrators. It also eliminates some of the dependencies on physical infrastructure. So the tier 0 remains untouched. The tenant has the ability to administer and configure services in multiple segments behind it. And then if we're using BGP, it'll automatically plumb and advertise those networks to the physical environment. Any questions on the multi-tier topology? All right. The last component for the edge nodes is the edge clusters. So when I create an edge node, you'll create, in most cases, 1 to 2, at least 1 to 2. You can scale up to 10. And then you'll define an edge cluster for those edge nodes. And then you'll configure the tier 0 and tier 1s on top of that. In this design, I have all edge nodes in a single edge cluster. I might be using ECMP at layer tier 0 for active-active uplinks. And this is kind of used for simplicity. Then I configure my tier 0. When you configure your tier 0, you'll define it at a high level, and then you'll configure each of the uplink interfaces on the edge nodes and tie it to its peer network on the physical side. You can also define stateful network services for the tier 1s to be active and standby on the same edge cluster as well. Something to keep in mind is that an edge node can only have one tier 0, but you can have many tier 1s behind it. So you'll see here I have active standby. I could define another edge tier 1 with active and standby, and then you'll notice that the shaded out is the standby. The dark color is the active for each of those. So you never want to put 2 active tier 1s on the same edge node, although you can. It is recommended to separate them from each other so that you have, tier 1 active services running with your tier 0 and maybe a standby tier 1 on that same edge node for another tier 1 that might be running active on another edge node. This just gives you greater flexibility for providing those stateful network services for the tier 1. Again, if you don't define a tier 1 with stateful services, you don't have to configure the edge node configuration on the tier 1 gateway, meaning it runs in DR only mode. For scalability or for heavy services usage, you can define 2 edge nodes in this architecture, and I might have my tier 1 for north to southbound connectivity. And then I'd have a second edge node cluster where I define active and standby services for my tier 1s for those high bandwidth services that are running inside of my tenant environment. So again, providing you flexibility in the architecture, providing you flexibility in how you deploy these edge nodes. And these edge nodes can be both physical appliances. We have bare metal, what we call bare metal edge nodes, but you also can deploy virtual appliances as well, depending on your compute resources, your edge node cluster environment. You could have many edge node virtual appliances running, or you could have, very large bare metal appliances. Any questions on this? Pause for a second. All right, the last piece is distributed firewall architecture. So not sure if everyone's seen kind of how NSXT changed or revolutionized how we provide firewalling, but it was a way for a lot of customers to move away from these traditional segmentations where I'm defining my network policy based on an appliance or a context within a firewall. I could have DMZ application database here, and then you have another internal firewall that protects your services, Active Directory, NTP, DHCP, DNS, your cert provider as well. What NSX provides is the ability to take the firewall that's based on a context, and in the case of like an application, if each of these were, a single application with web app database, there's nothing preventing the database from this application talking to the database on the same segment. There's no prevention of lateral movement of traffic or attack within the data center or within the application environment. And NSX provides the ability to group those virtual machines logically independent of the network architecture, and then provide firewalling stateful inspection at the virtual NIC of every virtual machine. So what we now have the ability to do is logically align security policy directly to the virtual workloads and provide more in line with what zero trust or least privilege models have been, touting for some time. In the past, it was very complicated and very cumbersome to deploy an architecture like this. But now, transparently to the physical network, our existing network or security services, we now have an inspection point that the VM, workload cannot touch. So if an attacker does gain access to one of the workloads. They can't sprawl their attack, even if they were able to shut down things like antivirus or host-based firewalls. The firewall sits in line at the virtual hypervisor, or in some cases it would be like at the bare metal workload, and then we provide the security policy at that point of inspection. So again, network topology agnostic as well as transparent to existing network and security services. I've had plenty of customers who, actually one of my customers I worked with, they wanted to deploy microsegmentation. They had a security audit that highlighted some vulnerabilities, and we were able to put all of their VMs on the NVDS VLAN-backed network, so the gateways and security policy at the firewall, perimeter firewall, stayed the same. And then we implemented a microsegmentation service at the VNIC of every virtual machine. Their entire production environment now had zero trust in a matter of days versus having to re-architect the network over a very long and extended period of time, and then having to re-architect their existing firewall policies was going to be a nightmare as well. So we simplified all of that, grouped our virtual machines very similar to this, based on logical tags, and then we were able to apply policy to those virtual machines based on the tagging system. And then kind of leaning back to where I mentioned, it's a layer 2 through 7 stateful service. You can see here, this is the UI for NSXT 3.0. We now introduced distributed IDS. We also have URL analysis. And one of the things I didn't get a chance to kind of pull into this slide, but I did mention was the NSX intelligence. That's under plan and troubleshoot. Traditional, or I should say legacy NSX environments relied heavily on vRealize Network Insight to provide analysis and mapping of application dependencies. NSX Intelligence provides that kind of internal capability, a snapshot of the environment to show you live application dependency and communication paths, and then from that, we can actually deploy recommendations for microsegmentation or distributed firewalling services directly inside NSX versus VRNI, where it might give you a recommendation for microsegmentation rules, but then you'll have to manually write them back inside of NSX. So this is a way to automate some of that function and inspection of service and traffic. So kind of talking about NSX everywhere, where we provide those firewall services. Again, you can run it in native public cloud with NSX Cloud. VMware Cloud environments like VNC on AWS, you can provide the same network services as well for enforcement of things like stateful inspection of traffic, 5-tuple, app ID, FQDN and URL analysis and user ID inspection. We do microsegmentation for overlay back workloads or VLAN back workloads. And then, automate drafts and rollbacks with the distributed firewall as well, which is very important, or a very cool feature inside of NSXV that we've now rolled into NSXT as well. So this is kind of just one of those cartoony highlight slides, but it does, identify, where NSX runs. Again, the virtual distributed switch, or NSX NVDS, runs on both ESXi KVM, but it also can run as a shim on the virtual or bare metal workload, excuse me. And then we apply the firewall at that layer as well. And I'll drill into how that works in a little bit. But what is important to keep in mind is that we configure via the NSX Manager cluster, via the UI, REST, or a cloud management platform, and then we push down via that local control plane agent. That local control plane agent then configures the NVDS and distributed firewall policy down at the host layer, and it maintains the IP database and updates any IP discovery mechanisms. The distributed data plane provides that program data path at the VNIC for layer 3 and 4 rules, and then it maintains a flow state table, which I'll talk more about in the coming slides. And then via the management plane agent, the MPA, is where we update stats and status and provide information from the transport node itself back to the NSX Manager to show things like rule hit counts, rule popularity, that kind of thing. The distributed firewall, it runs as a vSIP kernel module. So if you CLI into your ESXi host, you'll see that kernel module running vSIP, and that is our distributed firewall kernel service module. And it maintains, again, that rule and flow table. And I'm going to walk you through a packet walk as the VM is talking how this all works underneath the hood. But one thing to keep in mind that I tell customers time and time again, is the applied to field is probably the most important field in the 5 tuple, because unlike traditional firewalls, the applied to field can be things like a network security group. It just doesn't have to be just a flat network. So you could apply it everywhere and say, I want to apply it to the distributed firewall layer, which means everywhere the distributed firewall, that rule is going to be applied. But if I tag that VM and I say, hey, you're a web virtual machine, you're an app virtual machine, you're a database virtual machine, they have standard port and protocols that they use. I can immediately tag all of my database virtual machines, and wherever that firewall is, I only want to apply on those database virtual machines. Or if it's a production virtual machine, it has specific access to specific services. You can define that based on the rule table that you define and make that applied to field work for you, and instead of the firewall, being overrun. So here's kind of a bit of a packet walk. You'll have to forgive me. It's a little bit. It's going to get a little bit filled out in this slide, but I hope it makes sense. But first step, VM's going to generate a packet. This is a web virtual machine. It wants to talk to an application virtual machine on port HTTP. This is going to send a TCP SYN. That's going to be inspected at the flow table. If the flow table does not have a record in the flow table, what it does then is it sends it to the rule table for a lookup. So since the flow table is missing, we do a lookup on the 5 tuple match for a 5 tuple match. We find that match. It then updates the flow table and says, hey, I found a match. Make sure you track this so that we don't have to do a lookup again. And it updates the flow table, sends the packet on its way. Then every further packet is then looked up at the flow table, and that packet's then sent on to its destination. Could be a web virtual machine on the same host. It could be a web virtual machine on a different host. It doesn't really matter. The one thing I did want to highlight here is that you can see here, this is the firewall engine, the kernel module. This is also where we do our deep packet inspection, things like IDS, and then context engine as well, things like user-based access, RDSH sessions. We do context engine to manage those logins and firewall policy application as well. If I had a virtual machine, Windows virtual machine, and I had multiple users logging into that virtual machine to access an internal application, I could have Bob from finance, Sally from accounting, or I should say Sally from engineering, and Tom from HR. They can all log into that same virtual machine, but when they try and access the application, we monitor and maintain that traffic and flow table so that it says, Bob can only access, finance, Sally can only access engineering applications, and Tom can only access HR applications. So it's great for that. And we see a lot of that used for contractors within environments as well. Some best practices I wanted to share. So always refer to release notes on the newest capabilities and recommended configuration maximums. We have a great config maximum tool if you're ever concerned on what's limitation. We exclude management components from firewall policy enforcement. So make sure if you have multiple NSX team managers inside of the environment managing different vCenters, and you're synchronizing policy, make sure vCenter, make sure NSX Manager, VRNI, Log Insight, other visibility tools that you might be using are excluded from the NSX distributed firewall policies. The other thing is choose the policy methodology or role model that enables optimal groupings for microsegmentation. I tell customers not every firewall rule is going to be applied the same. It may be different for, based on application to application, tenant to tenant. So make sure you're grouping as optimally as you can. And use the tagging and grouping construct as best you can, because that could automate a lot of the functions. So if you're integrating with vRealize automation, they have the ability to tag a virtual workload as it's deployed, and that could associate directly to a security policy. So it's automatically inheriting that policy versus every time a new application comes online, you're having to recreate the wheel and redefine a policy just for that new tenant or new application. If you use a tagging model correctly, it should automatically apply that for you, and then you can just audit that application to make sure that the policy is applied correctly. Consider flexibility and simplicity in policy for day 2 operations. So you want to keep it as flexible as possible, going back to that bullet point number 3. Leveraging distributed firewall sections to the group and manage policies. So you'll see here that inside of the UI for distributed firewall, you have a section for emergency, which might be like, hey, we have a new application coming online, or I'm troubleshooting an issue with an application, and I want to create a firewall rule on the fly. You might use the emergency section to kind of get that application up and running, and then view where the firewall rule policy is being impacted or impacting the networking services of that application or virtual workload. Yeah, another section for infrastructure. I tell customers, if you have infrastructure services running, you may want to write firewall services inside here to protect and isolate those infrastructure services. Here we have environment. I associate this to prod, dev, test. Then you have application or tenant-based sections for writing those firewall rules that drill down into the application and have fine-grained policy enforcement. And then the last thing is use whitelist model. We always recommend this. So explicit deny all. And then you only allow the traffic that is meant for that application. So you're writing allow rules, and then at the very bottom you deny any as your default rule for policy enforcement. Any questions? No questions? All right. I guess with that, here are some learning resources that I'd like to share. I'm sure everyone here is very familiar with hands-on labs. There's some great labs that are currently available. This VMworld, I know they're getting ready to release, even though it's all virtual, we're going to be releasing new hands-on labs for NSXT. NSXT's distributed firewall and Lightning Lab is great for just a quick overview of what you might use distributed firewalling for. App Defense is another great tool that integrates with NSX and how we provide automated security and recognition of application services. NSX Cloud, this is using public cloud security services inside native AWS and Azure. And then vRealize Network Insight, this tool can't be highlighted enough as being essential to NSX, because this is, again, if NSX intelligence is a point in time realization of application dependency, this is a historical map of your application and network and security services inside of a data center. It integrates with both physical and virtual network and security appliances, your Cisco's, your HP's, your Dell, your Arista's, Juniper's, and it has visibility into all of those network and security services across your fabric. And then last is vRealize Log Insight, vRealize Automation. So if you want to see the vRealize suite, creating your own private cloud environment, and how to troubleshoot and provide compliance, vRealize Log Insight is very heavy into providing that syslog capability. Some reference materials here. I always recommend, as we said before, reading release notes and documentation. Great for guides. I'm sure everyone's been around each of these. One thing that a lot of people don't see is the NSXT 2.0, which is referencing NSXT 2.5, but it is the reference design guide. This is my the holy grail of answers when it comes to architecting NSXT inside of a domain or inside of an environment. There's YouTube channel, there's blogs for NSX virtualization, and then some guides on distributed firewalling. So I find that a lot of my customers ask, all right, NSX, provides these this great capability, microsegmentation and zero trust. Where do I start? And security admins are usually the ones that get confused the fastest, because they're like, I have an IP subnet, I have a gateway that's a firewall. It provides me my microsegment, or provides my segmentation of my network and inspection east to west, or north to south, I should say. But what does east to west really provide me? These guides provide a deeper dive into what microsegmentation and zero trust really provides, and the design guides are really helpful with kind of walking through how that works. And then the vRealize Network Insight YouTube, there's a lot of great videos on standing Network Insight up and using it optimally, operationalizing it inside of a production environment for visibility and network and security services. I guess with that, any questions? Does anyone want to see a demo, or do you guys want to skip that?
No, might as well see a demo.
All right. So let me just share. Hold on. Come on. All right, does that look a little bit better?
That looks good.
Yeah, looks good for me.
All right, perfect. So this is NSXT 3.0.1 that I have deployed. And then the one thing I do want to highlight is this is my vCenter environment. So inside the vCenter environment, I have a compute cluster, a management edge cluster. I have my edge nodes configured here. You'll see that I have no, this cluster is not prepared for NSXT. This cluster, the compute cluster is, and in legacy, or I should say previous versions of NSXT 2.5 and before, you'd have to define a NVDS. Inside of the vSphere 7 and NSXT 3.0, we can actually deploy the NSX virtual switch directly on the VDS that's configured on the host. And how I can tell that it is prepared is I see VMK10, which is used for what we call VXLAN, that overlay technology for capabilities. And then we have a hyperbus for our containers. So in vSphere 7, obviously you have the ability to integrate containers. So then we have the VMK50 and VMK10 deployed on there. So just real quickly, I want to show that. If I go over here to the management host, I look at the VM kernel ports, I only see VMK0, 1, and 2. So again, it's not prepared for NSXT. My compute cluster is. So in the NSXT 3.0.1 interface, you'll notice that there's no longer the advanced UI. And the reason that is that we are starting to incorporate more and more in the policy or the declarative API of NSX. We still have the imperative API, the management interface here as well, and you just toggle between both of them if you need it. And then real quickly, if I were setting this up from scratch, the first thing I would do is I'd go to System, sorry for the lag here, I'd go to Fabric. You'll define a compute manager. This is important because this is associating our vCenter to the NSXT manager so it can pull inventory from the vCenter appliance. And again, this has, because it's 3.0, it has the default overlay and VLAN transport zone already defined. Take a step above and I'll create my profiles for my uplink profiles. You can use the defaults for NSX edges and uplink for host switches. You can set your network IO control profile. What I was mentioning earlier here was the transport node profile. So I created this on the fly before I prepared my transport nodes. And as you'll see here, I no longer have to define a lot of the components that were defined inside of the traditional, or I should say legacy NSXT environment. I select that I want to use my VDS. Work is right for now. I'll select that I'm going to use the existing VDS. I'm going to use my mode as standard. And you'll define the VCA, the lab VDS that you're using. You'll then select the transport zones you want to include in that VDS or on that VDS. You'll define your TEP pools. And then last but not least, you just define your uplink and your team policy. So I see here I'm using uplink 1 is active, uplink 2 is standby, and I associate uplink 1 and 2 from the host. And that's it. So that creates the profile. And then I go to my nodes. And I'll see here that I have a KVM host prepared. And I went through and I manually configured that. But if I go to the vCenter appliance and I look at the inventory, I can see that I've already applied my profile here, my transport node profile that I created, to both of these ESXi hosts, and that pushed the VDS configuration to the host itself. The next component I'll deploy is an edge node. I deployed 2 edge nodes in this environment, so edge node 1 and edge node 2. Once I deploy them, you configure them. Let me just edit this guy real quick and I'll show you what it looks like. You'll define, again, very similar, you'll define the VDS that you want to configure on the edge node. You'll include the transport zones. You'll define the TEP pool because these edge nodes do require a TEP and these are virtual appliances. And then I'll define my uplinks for uplink 1 and uplink 2. In this case, I'm using active-active ECMP configuration for the edge nodes. So I define both active uplinks. Then I create my edge cluster with both of those guys. So I select my edge nodes, select them, put them into an edge cluster, give the edge cluster a name, and then I'm off and running to the races. So now I'm prepared to start deploying logical networking services inside this environment. So real quick, without going too much further into the system settings, what I have deployed, and this is new in NSX T30, is topology. I've deployed a T0, and I have ECMP routing via BGP to 2 virtual routers inside of my lab. And then I have a T1 gateway, which is peered with that T0, and you can see the intra-router link. So I click on this guy. I can actually see details here. Takes me to the T0, drills into what it is. You can see the configuration here, active-active mode. I can see the interfaces that are configured on it, my routing protocol, BGP is what I'm using down here. And then I can see my BGP neighbors as well that I've configured to communicate with on the physical side, both IPv4 and IPv6 neighbors. We'll get to that later. The other thing to keep in mind is route redistribution. If I don't want to redistribute all my routes, this can be editable, but let's take a look right here. So in this redistribution, I'm redistributing all static routes, all connected interfaces. So these are the downlinks from the tier 0, and then advertising from the tier 1, any NAT IPs and connected interfaces as well. So I can very cleanly select what I'm going to redistribute back into my physical network. And then going back to the topology real quick, because I think this is probably the coolest new feature, is, let me zoom back in. I can select one of these overlay segments and it'll pull out and show me all the virtual machines that are configured. Web 03, for instance, is running on my KVM virtual host, and then Web 1 and 2 are running on my ESXi host inside the ESXi clusters. My database is also running on my KVM host, and then to prove out that this is all working, if I go to my 3-tier app, everything's kind of coming. I can see that I'm hitting, I have a load balancer in front of this. I should be hitting one of my other web virtual machines, but it looks like web virtual machine 1 is the only one responding right now. But usually I would see web 2 and 3 respond as well, and it would load balance between the 3 of them. I have to check my load balancer configuration or see if I turned it off. I guess any questions? Would anyone like to see anything in particular? Oh, I should note I don't have NSX intelligence deployed, so I can't use the plan and troubleshoot for NSX intelligence in this lab, unfortunately. All right, I guess one last thing I'll just show is just the distributed firewall. This is looking at the application level, but you can see here, as I mentioned before, you have emergency, infrastructure, environment, and application. I have an identity-based firewall rule that allows HR to access HR, finance to access finance, and then I have AD integrated with my NSXT managers, and inside of this guy, I'll see that I have group definition, my AD group for HR is defined. So anyone that logs into via RDSH, going back to that topology, there was an RDSH virtual workload. When anyone from HR logs into that, it'll have access to only the HR applications inside of the environment. All right, I guess if there's no other questions, I will go ahead and give up my time. Thanks, everyone.
Cool. Thanks, Aaron. That was super cool.